Here is a parallel circuit. A parallel circuit is way more complicated than a series circuit. As you can see, there are multiple paths for the current to flow. You can see that we have the total current along this section of the circuit. And then when the current gets to this part, it has to go ahead and split and go through each of the branches. So you can see I have the green current coming down this branch and going back to the battery. You can see I have the purple current heading on back to the battery, and I have the orange current heading back to the battery. And here you can see if I add up each of the three currents, it's going to go ahead and give me the total current. That is Kirchhoff's junction. Kirchhoff's junction rule. And it states that the total current in a parallel circuit is all the other currents added on up together. Next point. Implies that this resistor is connected to the battery directly. This resistor is connected to the battery directly, and your final resistor is also connected to the battery. So basically, we know that the total voltage is equal to the voltage in branch 1, which is equal to the voltage in branch 2, which is equal to the voltage in branch 3. And that's why I wrote 9 volts here, 9 volts there, and 9 volts there. The third piece of information you need to know about parallel circuits is calculating the total resistance or the equivalent resistance. The formula for that is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. There's a fantastic button on your calculator which is going to do it all for you. It's your -1 button. So if I was doing this in the calculator, I would simply go ahead and say the total resistance is going to be 10 to the -1, 10 to the -1, plus 10 to the -1. I would take the x to the -1 of that again, put it into the calculator, and I am getting 3.33 ohms. So that's how we are going to go ahead and calculate the total resistance in a circuit. Now, a little piece of advice. This answer will always be less than the smallest resistance in the circuit. Okay, so let's go ahead and we'll take a look at a little bit more complicated parallel circuit that is in your notes. Basically, it says, it's the bottom question, 3 unequal resistors are connected in parallel across a 12-volt battery. Okay, obviously you can go ahead and color in the current going through each of the branches. That's exactly like I showed you a few minutes ago. But let's go ahead and we'll jump on down to part number 4. And part number 4 asks you to calculate the total resistance of the circuit. So the total resistance in this circuit is going to be 10 to the -1 plus 5 to the -1 plus 20 to the -1. And I will take the -1 of that. And let's go ahead and we'll put that into the calculator. So we can get 10 to the -1 plus 5 to the -1 plus 20 to the -1 -1, and that gives me 2.86 ohms. So that is where I'm getting the total equivalent resistance. So part 5 says to us, calculate the current measured in ammeters 1, 2, and 3. Well, let's call them I1. Well, we know that current is going to be V divided by R. So the voltage stays the same, so that's going to be 12 volts. I have 10 ohms in resistor number 1. 12 divided by 10 is 1.2 amps. If I want to go ahead and calculate the current in I2 current, it's going to be the voltage divided by 12 volts. The resistance is 5 ohms, and 12 divided by 5 gives me 2.4 amps. My third current is still going to be V over R, so that's still going to be the 12 volts, but this time we're going to divide it by the 20 ohms. 12 divided by 20 is 0.6 amps. So that's how we can go ahead and calculate the branches. And then finally, we can go ahead and calculate the current measured by the ammeter connected in series to the battery. Well, that's basically the question's asking you, what is the total current? Well, there's a couple of ways to do this. We can say, well, it's the 1.2 amps plus the 2.4 amps plus it's 0.6 amps. So that is going to go ahead and give me the 4.2 amps. However, I could go ahead and say the total current is going to be the voltage divided by the total resistance. Voltage was 12.5. You worked out that the total resistance was 2.86. And when I go ahead and put that into the calculator, I am still getting 4.2 amps. The little boxes off to the side with the VIR is just work, the shortcut version of working out exactly the same thing. So let's go ahead, and if you do like those little boxes, well, let's take a look at it. I've got my V, my I, my R. V equals I times R. That's going to be R1, R2, R3. So there's R1, R2, R3. This is going to be my total. My R1 was 10 ohms. My R2 was 5 ohms. And my R3 was 20 ohms. Now remember, we do not add those up. That only happens in a series circuit. So we need to go ahead and we need to do parentheses 10 x to the minus 1 plus 5 x to the minus 1 plus 20 x to the minus 1. Take the close the parentheses, take the x to the minus 1 of that, and we end up with that 2.86 ohms. And I'm just going to put x to the minus 1 there to remind you that's the button we should be using. The voltage in this circuit was 12 volts. According to Kirchhoff's junction rule, the 12 volts is the same everywhere. So now I can go ahead and say I equals VR, 12 divided by 10, 1.2 amps. 12 divided by 5 is the 2.4 amps. The 12 divided by 20 was the 0.6 amps. I can add those all up, which is 4.2 amps, or I can do 12 divided by that, which gives me also the 4.2 amps. Again, just like in my series videos, I don't care if you work through this type of math, and what we did about 3 minutes ago. You do the little VIR tables. You just have to be able to understand what is going on for your quiz next week. So that's parallel circuits.